For this section, we're going to take a look at how Python utilizes and treats strings. String, if you recall from the homework assignment, is a sequence of any characters. It can be a single character or it can be a string of characters, up 256 characters or beyond these days. There used to be a limitation, but typically today it could be a sentence, a paragraph, or even a page or more, a very long string of characters. So a string can be short or long or anywhere in between. We typically designate character strings by putting quotes around them. And you can use either a single quote or a double quote, but be consistent. And there are some particular things that you'll have to pay attention to, notably mixing the two together. If you'll see in the bottom example here, where it says, "Say it ain't so, Joe," note that there is a single quote embedded inside of these two double quotes that encase the string. You can get away with that so that anything within the quotes becomes interpreted as a literal character. And in other words, it won't be interpreted as a command or a formatting type of a character sequence by Python. So we had numeric variables that we worked with in the last session, and we also have the capability of having string variables. Now Python is a very loosely typed language. That is, you do not have to declare your variables before you can use them. It pretty much just creates them on the fly. So the first time that you use them, they are created. And they are often used as an argument to a print statement. One of the other things that you need to understand about strings is that you can address them or manipulate them based on the positional index of where a character might first appear in a string. And as with the usual programming parameters here, we always start counting with 0. So the first character in this particular string of spam and eggs, the first character would be found at position 0, and so on up through the last character at position 10. Now always remember that you have to also keep in take into account punctuation and things like spaces, periods, commas, all those things. They count. They take up a character just the same as a regular letter does. There's an example where we create a variable called string1, and we can address certain elements, sub-elements, if you will, of that string through this particular notation of enclosing the positional index within a set of brackets separated by a colon. Okay, get my pointer going again here. So here is the syntax that we would use to identify a certain sub-element of the string. The example, spam and eggs, characters between 2 and 7. So that includes, now this is one of the things that will catch you if you're not careful, because when you look at this kind of thing, you automatically have a tendency to revert back to counting 1, 2. You have to remember that you start counting with 0, otherwise you'll end up pulling stuff from the wrong position. So 2 begins here with the A, and then it stops at the 7th position. So it's not quite as intuitive as you might think. It does require a little extra attention. So the space between 2 and 7, it is indeed 5 characters, but you have to think about exactly where it's operating, and some of our exercises will help you with that. Here's some examples. Print Python does this. It just prints the word Python. Print Python, but only the first positional, not the first character, but the positional index of 1. So that's the second letter of Python, so that's Y. This is what is in the 5th position, so it's actually the 6th letter. 1, 2, 3, 4, 5. All right. Now wait a minute. 1, 2, 3, 4, 5. Oh, 6. N. So that's N. That's it. And then this one is showing you the range. So beginning at the third character actually, which is the TH that's being pulled out. 0, 1, 2, and 3. So not the fourth character. Alright, so here's another string. This string has the characters hello world with an exclamation point in it. And here's another method that you can use with a string function. We're going to take and do a find on the variable string1. The dot operator separates the string from the function or the method. And we're going to look specifically for the capital W. Notice this is enclosed in single quotes. So when you execute this, it will return 6 because the W, the capital W, appears in the 6th positional index. 0, 1, 2, 3, 4, 5, 6. So this statement will return the positional value of where in the string this letter occurs. Same thing happens here with X. Oh, no, it doesn't. Look, X is not in this string. So this is a way to evaluate whether or not a string actually contains a certain character. So it's possible to identify that you actually do not have an occurrence of a particular character or even string within another string. That would return a -1. So you can test that as an exit value of your function. Here's another refinement to the find command, which says to start searching from the R right end of the string. So start searching from the right end, looking for the letter L of this particular string, hello world. And it finds the first one here, which is actually the 9th positional index of that string. It is also possible to use negative indices, which is not too common, but it is possible. If you're indexing from the right, you have to think about that. So we're not going to go into details here, but you use negative numbers for indices when you're starting from the right and moving this way. And then, of course, notice we don't start at -0 because there is no such thing as -0. 0 is just 0. Another example. This one illustrates using the negative indices. Python -1 is going to return in because it's the, in this case, first element from the right. -4 is going to return the T, -1, 2, 3, 4, and so on. Here's the string spam and eggs. Return -2, that should be a G. Return a range from -8 to -3, so that's -1, 2, 3, 4, 5, 6, 7, 8. Let's pick up the M and then go back the other direction. 8, 8 minus 3 is 5, so we'd have a total of 5. 1, 2, 3, 4, 5 stops with the E. And that's what we see down here. All right, moving along. There are certain default boundaries when you're working with this. In this particular example, you can take a look at it and see that similar to doing a print job in Microsoft Word. If I was saying print pages 2 through and I didn't put anything in the end, it automatically assumes that you want to go all the way to the end. So it prints the whole thing, beginning at 2 and out through the end. Same thing applies from the beginning. It says if you omit the first element, it assumes you want to start at the beginning and stop at the 4th character, and so it would print the first 4. If you omit both, which is kind of silly, you might as well just say print, but if you did omit both, it would default to the beginning and the end, therefore it would print the entire string. String concatenation is a concept that you're not going to probably run into anywhere else. One of those peculiar words unique to programming. Concatenation means sticking two strings together, combining them. So there's different ways that you can join strings. The operator is a plus sign. So we'll combine a couple of strings using a plus sign or other functions and methods as well. And the end result is something we call a string expression. So here's an example where we're doing a repetition where we want to just duplicate something. Notice we have ha in quotes and we're saying times 4. Now this may seem counterintuitive to be able to take numeric variables and integer variables and do operations on them, but we can't actually do this because we're just multiplying that string by itself 4 times, so that your value or your result is this. Same thing with murmur. And here is an x times 10, which gives you 10 x's. So you begin to get the idea that you can manipulate strings in the same context or idea that you can manipulate numbers in math. Here's an example of some of the different functions that are available to manipulate strings. We can look at a function that returns the length of a string, brings back an integer value, number of characters in the string. We can have other functions that convert the case from upper to lower. That can be useful if you're doing passwords or some other things along that line. You can do a particular count of the occurrences of certain letters or substrings within another string. Then you can do some rather unusual things that are a little peculiar to Python here in terms of, for instance, capitalizing the first letter and lowercasing the rest, or putting it into a title format where the first letters are capitalized. And then there are other things that allow you to perhaps strip out spaces, for instance, from the right side of a string. So string operations. You can also chain methods together. This is a little more advanced concept. I don't think we'll be getting into too much of this, but it's one of the peculiarities of Python that you can take multiple statements of code and sometimes combine them in a method that is very efficient, but sometimes a little cryptic to read. Let's also take a minute and talk about the input function. This one is real fundamental and basic, just what you would expect. The word input is the command, and then the text would be the prompt that goes to the screen. Then whatever the user inputs, that value then gets assigned into the variable over here on the left. So this is how you get input from a user from the command prompt. Here's an example which does an input and also does a little bit of string manipulation. So we're going to ask an input a full name from someone. The results of that will go into a variable called full name. Notice the camel case going on here with a capital N. Then we're going to take the value that's in full name. We're going to use the method rfind, and we're going to look for the first occurrence of a space character. This will help us to separate the first name from the last name. We're going to take the positional index of that space character and assign it to the variable n. Then we're going to print some output to the screen called last name, colon, comma, then the actual value, not the entire value of full name, but a positional, a partial value beginning at n plus 1, because remember n was where the space was, so we want to start at n plus 1, out through the end of the string because we've omitted a value right here. So that will print, as you can see, here's the text. We enter full name. What was entered was Franklin Delano Roosevelt. This print statement prints this last name, Roosevelt, and then the second print statement prints the first name or names. And again, in this case, it starts at the beginning of the string and prints everything out to the value of this last space character. So we get that. Here's a few more functions that can be done on strings that help you do conversions, because it's not unusual to grab input from a source, whether it's a file or a user, and have it end up being a string, even though it's numbers. And in order to do math on the numbers, you have to convert it from a string to an integer or a numeric, some kind of a numeric variable type. So the int function or integer function takes the value of a string 23 and converts it to a number. If you use the float function, you get a floating point number, 23.0. And then you also have the ability to just do an eval on it, which essentially does an evaluation or calculation. Sometimes might be a better way of looking at it. But again, it converts it from a string to a numeric value that you can use in some other part of your code. Here's a few more examples. If you do an integer of 4.8, you're going to get 4. Minus 4.8, you'll get minus 4. And so on. Floating point does the same thing. And there is an str function that just literally converts a number to its string representation. So that's going the opposite direction. It's taking a number, turning it into a string. As you're developing your code, it's important to make sure that you document as you go. Now initially we're writing real small little snippets of code which really don't require any documentation, but the more code you write, the more you need to be thinking about documentation, because as you go through and solve little parts of the problem and you write code for it, you need to be able to put some comments in there that discuss exactly what it is that you're doing. It makes it much better to understand the program when you go back at some later date to reread it and figure out what it was that you did, because perhaps you want to make some changes to it. So always try and document your code. The comment character in Python is the pound sign. So any place you put a pound sign, it reads that as a comment and ignores it. There's also the idea of line continuation. When you're writing code, it's quite common that you might end up with a piece of code that's fairly long and doesn't fit very well on a screen. You can break it into 2 lines and not have the interpreter look at it as 2 lines, but look at it as a single line by using the / character, or you can also enclose it within the parens. That will accomplish the same thing. It's more of a personal preference which way you like to do it. All right, little warning, I guess, here about slicing things that are out of bound. If you index something out of bound, you'll get an error. Example, if you assign a 6-character string into this variable, and then you try and print the 7th positional value of it, and that's not going to work. You're going to get an error. So if you go out of bounds, don't be surprised when you get an error. And that concludes this little session on doing strings.